starts from random forest. As a name itself, forest, so it's comprising of multiple trees. So you are taking decision from multiple trees. I hope my sound is audible.
Yes, sir. Yes, sir.
Okay, thank you. So you are collecting data from multiple decision tree and you can make a best decision. So based on majority vote, you can make a best decision. So that will be termed as random forest. Here same thing, random forest for regression, and we have applied random forest for classification too. So random forest for regression, then second one random forest for classification. Then how to plot a data in a graph. So random forest as well as random forest classification. So both the result which will be plotted in a pie chart or otherwise bar chart or something, a linear chart. So you have plotted in a graph. Then always any machine learning algorithm or deep learning algorithm is concerned. Performance metrics which plays a vital role. So the basic performance metrics which is named as accuracy. So it's for regression performance metrics. Then absolute error, mean square error, root mean square error. These are the some basic metrics under regression. If classification is concerned, we need the different performance metric. Here the name of the performance matrix which is named as confusion matrix. With the help of that confusion matrix, we are providing three excellent metrics named as precision, recall and F1 score. This is a small agenda for this day 3. So starts from a small intro on random forest. So random forest, as the name itself, a forest, so collection of decision tree. A forest in the sense which comprising of tree 1, tree 2 as well as tree 3. So you have collect the data based on majority vote, you have to select a best one. So random forest as a name itself, it's an ensemble based learning algorithm based on many decision tree. So random forest is an ensemble based learning algorithm which based on the decision which is based on many number of decision trees. So here this is an example. So we are having collection of fruits. So based on tree 1 which says it's a apple. So I take a fruit and tree 1 I have analyzed via decision tree and tree 1 says I have taken the fruit as apple in class A. So in tree 2, in decision tree 2 which analyze the data and which pruned via decision tree. Sir, please unmute. Sorry, please mute. Okay, thanks. Okay. Yeah. So I have picked a fruit. So tree 1 which says the fruit is apple. Tree 2 is pruned in a different way. So the terminology was different. So the data set was pruned. So based on that which says it's again apple. But in decision tree 3, 4, 5, 6, 7, the nth decision tree which says the fruit was banana. So based on majority voting, the taken fruit was apple. Yes, fine. So you can make a decision from multiple decision tree. I have taken a fruit from the entire fruit bucket. So I have tested via decision tree 1, decision tree 2, decision tree 3, etc. etc. So I have compared based on majority voting. The majority tree says that the fruit was apple. So the final decision was the fruit was apple. This is what which is named as random forest. So which is similar to decision tree, but based on simply blindly you can depends on single decision tree. But here we are having multiple options. So you are performed via multiple decision tree and take a best decision. So this is for random forest algorithm. So the special feature of decision tree which is called as random forest. So random forest is a special feature of a decision tree algorithm. The tree should not be pruned. So each individual tree is overfitting, so not generalized well. So but it will be okay after taking a majority vote. So anyway, it's not perfectly pruned. So anyway, based on majority vote, you can take a best one. So I'm giving a small example. So all of them very much familiar about the story which will be called as Elephant and a Blind Man. Yeah, very morning session, so students are very much active. So anyway, all are very much familiar about the story. The story which will be named as Elephant and a Blind Man. So I will explain the story first and then I'm entering into decision tree algorithm. So once upon a time, there was an elephant in a village. Similar way, there were 6 blind men also living in the same village. One day, a villager said there was an elephant available in that village. So even though there are 6 blind men, so it's not possible to see the elephant. So at least went there and touch and feel the elephant. So the 6 blind men are went there where the elephant was and touching the different parts of the elephant. The 6 blind men are touching different parts of the elephant. And one of them said, it's like a wall. One of the blind men said, it's like a wall. Because he touching the part of the elephant. He touching the part of the elephant and said, it's like a wall. The second blind man touching the tusk of the elephant and said, it's like a spear. So touching the tusk of the elephant and said, it's like a spear. The third blind man touching the tail of the elephant and said, it's like a rope. Third blind man touching the tail of the elephant and said, it's like a rope. The fourth blind man touching the leg of the elephant and said, it's like a tree. The fifth blind man touching the ear of the elephant and said, it's like a fan. Fifth blind man touching ear of the elephant and said, it's like a fan. So sixth blind man touching the trunk of the elephant and said, it's like a snake. So 6 blind men are touching different parts of the elephant and argued with each other. So one of them said, it's like a fan, it's like a spear, it's like a snake, it's like a tree, it's like a wall, it's like a rope. So 6 blind men are touching different parts of the elephant. So which one is correct? So these are the 6 views. Similar way, the decision tree which gives their own view. So for the combination of all to provide an elephant. So pictorial representation of elephant. Similar way, the decision tree, the combination of all the decision tree. So you can get a best result. So one of the blind man is like this, another one blind man is like this. That's not a problem. So you can, blind man is equivalent to decision tree. So each and every blind man touching different parts of the elephant and says the result. So based on the majority vote, you can find the best result. So this is what which is called as random forest. So you can take a decision from multiple decision tree and get a best one. So translating it into little bit jargon based on our terminology, random forest is an ensemble classifier of many decision tree. Each tree casts a vote. Each tree can provide a vote, whether it's an apple or not, or whether it's an apple or orange or banana. So final decision which based on majority vote. What majority decision tree says. So the motivation of generating multiple tree is to increase the accuracy of predictiveness. So it can provide the best predictive methodology. So if one decision tree can provide a result, it's not the best one. So you can get the data from multiple decision tree and provide the best accurate result. So the predictive accuracy was more compared with decision tree. If decision tree the accuracy was 90%, if you are getting data from random forest, which will provide the accuracy of 99.9%. So that's what we are entering into random forest algorithm. This is a small overview of random forest algorithm. Then directly we are entering into our hands-on session. Yes. So the same problem statement. The problem here is to predict the gas consumption of the data set which is called as fuel consumption of a data set which is called as petrol consumption data set. So the petrol consumption data set which downloaded from the drive and saved in the extension .csv. 1 second please. Sorry, 1 second. So this is a problem, the same problem which is given in decision tree. So now the step number 1, it's the same step. I hope students are active. So same step was repeated for random forest regression 2. The same set of steps which is repeated for random forest regression 2. So the step number 1 for importing libraries. Step number 1 for importing libraries. So import pandas pd. So pandas is a library which used for data analytics. Pandas is a library which used for data analytics. Then numpy as np. Numpy is a data set which used for handling array. Pandas for handling data analysis. Numpy which used for handling array. So I am importing 2 packages. one which is called as pandas, another one which is called as numpy. So step number 2. Step number 1 for importing libraries. Step number 2 for downloading dataset. Here, this is a Google Drive. So here from that drive, one second. So I have pasted it in the chat box too. So the link was pasted in chat box too. So the data set which is available in the Google Drive. So I have downloaded the data set which will provide the file named as petrol_consumption.csv. The CSV file, comma separated value. So each and every data is separated by comma. So column separation which is made by comma. So I have downloaded a data set from the given Google Drive. Then using a pandas object. So using a pandas object pd dot read CSV. Read CSV is a method which used to read the data from CSV file and store it into an object called as dataset. So dataset is an object which used to hold the entire value of petrol consumption.csv file. So the CSV file which is read via PD. PD is an object of pandas. Pandas which used for data analysis. Yes, fine. Now the entire dataset for dataset.head of which choose to display the entire dataset. It's an entire dataset. I hope it's fine. So step number 1 for importing package. Step number 2 for reading data from dataset. Step number 1 for import packages. Step number 2 for reading data from dataset. Now for step number 3. Step number 3. The third step for preparing data for training. Preparing data for training. Here x equal to dataset dot index location colon 0 to 4. 0 to 4 in the sense it's a 0, it's 1, it's 2, it's 3. So 0 to n minus 1. 4 in the sense 4 minus 1. That is that. So 0 to n minus 1. So these 4 columns which is taken into x. The fourth column which is taken into y. The first 4 columns which is taken into x and the fourth column which is taken into y based on with the help of ILOC, index location method. So x equal to dataset dot ILOC 0 colon 0 to 4. So all the rows and 0 to 4, 0 to n minus 1, 4 in the sense 3. So 0, 1, 2, 3, totally 4 columns which is taken and store it in, the values are stored into x. And similar way y equal to dataset dot ILOC colon 4. Only fourth column which is taken into y. So x equal to dataset dot ILOC all the rows as well as 0 to third column, that is 0 to fourth column in the sense 0 to n minus 1 third column. So totally 4 columns are stored in a variable x, y which holds the fourth column. Then step number 4, dividing the data into training and testing sets. Dividing the data into training and testing set. From the sklan.model selection package, the method which is named as train test split. Train split is a method which choose to split our entire data set into 2. One for training, another one for testing. So 80% data which used for training and 20% data which used for testing based on test size equal to 0.2. So 20% data for testing, 80% data for training. So x train, x test, y train and y test. So x train and y train which comprising of 80% of data, x test and y test which comprising of remaining 20% of data. So now everything was fine. So step number 1 for importing package, step number 2 for reading data from dataset, step number 3 for preparing data for training x and y, then next for train and split 80% data for training and 20% data for testing. Now there is another feature, please listen carefully. there is another feature named as feature scaling. Another feature which is named as feature scaling. This is a new for random forest, feature scaling. Please see here. Please see here. Please see my data set. Please see my data set. So in my data set, petrol tax, the values lies between 0 to 10. In average income, values for 4,000, 3,000, 5,000 something. The paved way values are 400 to 2,000 something, 3,000. But in population driver license, it's in 0 to 1. In petrol consumption, it's 0 to 1,000. So all the values are not in a proper range. So you have converted it into proper range. It's our duty to use a scalar. So from the package sklan, dot pre-processing. So scaling is one of the pre-processing. So sklan dot pre-processing, I use a standard scalar. I use a class called as standard scalar. So I am using an object something sc, which is equal to standard scalar. So standard scalar x train equal to standard scalar dot fit transform of x train, x test equal to standard scalar dot fit transform of x test. So both the values x and x value, training and testing value, now changed into a proper scale. So a standard scale 0 to 10 or 0 to 100, it will be changed into a standard scale. All those values is changed into standard scale. Yes, fine. The entire value which is changed into a standard scale of 0 to 10 or standard scale of 0 to 100. So this is what new in random forest algorithm, feature scaling process. Now step number 5, the same thing. You are performing a training algorithm from sklan.ensemble, from the package sklan.ensemble. You have used a class called as random forest regressor. So from the package sklan.ensemble, I have called the class named as random forest regressor. So regressor, the object regressor, which is equal random forest regressor of, here you are passing number of trees. Here you are passing a parameter, the parameter as number of trees. Here you are passing the parameter as number of trees. So here the n estimator is an optional parameter. N estimator is an optional parameter. Here we are passing number of trees as 20. So in that algorithm, it automatically build 20 decision trees, based on majority vote. It automatically take 20 decision tree, and based on majority vote, which will provide the best one. Based on majority vote, which will provide the best one. So here n estimator equal to 20, then regressor dot fit same, x train comma y train. So the model was trained and built for 20 decision tree. The entire model was built and it will provide 20 decision tree. Now y prediction value equal to regressor dot predict of x test. So I have compared y predicted value with y actual value. Then it will provide mean absolute error, mean squared error, as well as root mean squared error. Mean absolute error, mean squared error, root mean squared error. Then now see the result. Here I am using 20 decision tree. So the result was 51.765. Actually error rate was less than it's good. Here error rate was 51. Okay. I have construct 200 decision tree. Then now error rate was little bit reduced. If 20 decision tree, the error rate was 51. If I have construct 200 decision tree, now error rate was little bit decreased. That will be called as 47.9, something called as 48. So error rate little bit reduced. So if you are built more number of decision tree, the result status was good. So this is a basic example. So this is what my first program. That's called as random forest regression. So I have opened a command prompt. Then I'm entering into my E drive and my folder named as sample. Then I have set a path API slash scripts. So otherwise I'm directly entering into Python. So directly type Python. So I'm entering into Python prompt. So I import a package. Import pantas pd and numpy np. So I am pasting here. Import pantas pd. So pantas which used for data analytics, numpy which used for pantas which used for data analytics, numpy which used for array handling. So now the two packages was imported. Now second stage, already I have downloaded a data set from the Google Drive and save it here. So data set equal to pd.read of read CSV. Yes, I have pasted here. So sorry, I have changed the. So now data set, I have print the data set dot head of, which used to print the heading of data set. So which comprising of 4 columns named as petrol tax, average income, paved highway, population, driver license. So sample data was displayed. These 4 columns are taken as X and petrol consumption, the last column which is taken as Y. Now for printing summary, data set dot describe of we choose to print the mean, standard deviation, average, max value of the entire data set. So it needed, you can view the same. Now fine. Now step number 1 was completed, that is importing packages. Step number 2, reading data from data set. Everything was fine. Now step number 3. Step number 3, first 4 columns which is taken as X and 4th column which is taken as Y. So printing X, yes, 4 columns is stored in X. Print Y, the 4th column is stored in Y. Yes, fine, everything was good. So step number 1 for importing package. Step number 2 for reading data from data set. Step number 3 for data, splitting data for training. Sorry, splitting data, preparing data for our algorithm. So next one, the standard scalar. I have applied a standard scalar. Sorry. Before that, I am performing the method called as train test split off. Inside the package sklan.model selection, I have included a package called as train test split off. So using the method, now xtrain 80% of data which stored in xtrain and 20% of data which stored in xtest. Same way ytrain and ytest, 80% data which is stored in ytrain and ytest. Now I am perform standard scalar. So now print the data. The data which is fit into same scale. All those data which placed into same scale. So something 0 point, which lies between 0 to 10. So which is in the same range, 0 to 10. So the same scale range, all those value was converted. That's called as future scalar. So scaling value, either for upscale or downscale the value into a proper standard scale. The standard scale which lies between 0 to 10. So the entire value which converted into the standard scale of 0 to 10. That's the use of standard scalar class which is available in something called as sklan.preprocessing package. Now you have call regressor.fitoff and prediction value. So random regressor, then y predicted value. Yes. Now print y predicted value, y underscore pred. Yes, it's a predicted value. Y underscore test, it's actual value. So actual value was 534, the predicted value was 574. So something, the actual and predicted score was taken. Now I have print the matrix mean squared error. Matrix mean squared error. The error rate was 51.76. The error rate was 51.76. Now I have changed this. Now I have changed this. Sorry. Now I have changed this into 200. I have changed this into 200. Now I have pasted it here. Now I have print the matrix values. So the matrix value was 48.33. So if the epoch value in the sense n estimator in the sense number of trees. If number of trees was increased, it will provide the best result. So now it's a time. Yeah, this is my program. Now it's a time to plot the value. So please see here. Plot the value. So I am using import matplotlib. Import matplotlib pyplot as PLT. So I am using a for loop. Please see here. For a variable n estimators in the array. So in the list. So first n estimator equal to 5. Second n estimator equal to 25. Third n estimator equal to 50. Fourth n estimator equal to 100. Fifth n estimator equal to 250. Sixth n estimator equal to 500. Now I have pasted here. Regressor equal to random forest regressor of n estimator equal to 20. If I am not provided value, which will taken 20. If I provide value, which taken that value. Okay, that's not a problem. So if n estimator value was not provided, then which take this default argument. If the value was provided via for loop, then which takes that. So which is taken. Then random forest dot fit something regressor dot fit x train comma y train, y predicted value equal to regressor dot predict of x test. Then plt dot scatter plotting n estimator. So 5, 25, then 50, 100, 250 and 500. Then comma np dot square root of matrix dot mean squared error. So its mean squared error was printed. So now plt dot show off. I have copied the content and paste it in my prompt. Please see here. Import matplot library, import matplot.pyplot. Then for loop was executed. Then which is plotted. Plot.show. Yes. If 20, the value was 65 all around, which is same. So sorry. I think yeah, which is nearly same. So anyway, I will remove this 20. Almost this data set is concerned, which is nearly same. I think so. Yeah, sorry. The 20 value was taken. Sorry. So now I have plotted the same. So the value was changed. So not default value. Now I have plotted the same. The value was changed. So n estimator equal to 20. So all those values are same. Now n estimator was changed. Now which plot a graph. Okay, fine. So based on that, if n estimator equal to 5, so the error rate was very high. But if n estimator was 500, so error rate was less. So this is what plotting value in a graph. So the next, yeah, at plot for plotting graph. Sorry. So it's a program for plotting it in a graph. So now we are entering into the second stage using random forest classification. Using random forest classification. The first one, which is called as random forest regression. So second one, which is named as random forest classification. Here, step number 1 for import library, import pandas pd. Step number 2, import numpy np. Step number 2 for reading data from dataset. Here dataset was bill authentication.csv. So dataset equal to pd.read csv bill authentication.csv. This is my dataset. These 4 columns which is taken as x, and the last column which is a classification class which is taken as y. So x equal to dataset dot index location of colon comma 0 to 4. So 0 to n minus 1 column, the 0 to 3, totally 4 columns which is taken as x. Y equal to dataset dot ILOC colon comma 4. So only 4th column which is stored as y. 1 second. So x equal to dataset dot ILOC of 0 to 4. So first 3 columns, sorry, 0 to 4, first 4 columns which is taken as y, x, and the last column which is taken as y. Now sklan dot model selection of train test split off. So 80% data which is taken for training and 20% data which is taken for testing, because the test size was 0.2. Feature scaling, we choose to scale our values into 0 to 10. Feature scaling, we choose to scale our values into 0 to 10. sklan dot pre-processing, from standard scalar, we are converting our x value into 0 to 10 range. Okay, fine. This is for feature scaling. Now for training algorithm, here only the changes random forest classifier. There random forest regressor, here which will be changed into random forest classifier. So classifier equal to random forest classifier of n estimators equal to 20, random state equal to 0. Classifier dot fit, we are passing x train and y train value. Then you are passing x test value for prediction, it will find a y predicted value. Then you will compare y predicted value as well as y actual value, then you can get a result. So for classification algorithm is concerned, we will construct a confusion matrix. We will construct a confusion matrix and accuracy score. So confusion matrix, I am passing y test and y predicted score, then classification report as well as accuracy score. So here this is called as confusion matrix. This is called as precision, recall and F1 score. Precision, recall and F1 score, these are the classification report. Precision, recall and F1 score is a classification report. Then its accuracy also printed, which is for 99%. So 98%, sorry. This is what accuracy, 98%. So here inside a package called as sklan.metrics, we will print confusion matrix, classification report and accuracy score. So now I hope students are very much clear about random forest regression as well as random forest classification. Now same way I am plotting it in a graph, n estimator, not this 20. So n estimator, I am finding the predicted value and then print the accuracy score in a graph. Yeah, this is what fine. So I am starts from linear regression. For linear regression for a data set as well as linear regression for array. After that I am entering into multiple regression. So multiple regression in the sense multiple columns are merged together. After that I am entering into decision tree classification. So for regression you can predict the exact value. For classification whether it's in group A or group B. Then we are entering into random forest. Random forest is an ensemble based algorithm. You can construct many decision tree based on majority vote. You can take the best result. So random forest for regression as well as random forest for classification. So these are the content which was covered in the for day 1, day 2 as well as 50% of day 3 too. Now we are entering into the core part that's called as performance metrics. How to evaluate the performance of machine learning model. This is a core part. How to evaluate the performance of machine learning model using confusion matrix, accuracy, precision, recall and F1 score. So I will take a small example. Let us consider a task to classify whether a person is pregnant or not pregnant. So let us consider a task to classify whether a person is pregnant or not pregnant. So yeah, now there are 4 cases. So point number one, A person who is actually pregnant, then system identified, the doctor identifies you are pregnant. So person is actually pregnant, system also correctly identifies the same. So that's called as true positive. Please listen carefully. Person was pregnant, system also identified the person was pregnant. So that's called as true positive. The second stage. So the person was not pregnant, system also correctly identified he is not pregnant. So that's called as true negative. So true positive as well as true negative. System can correctly identify. Then third stage. A person having big belly. A person having big belly. But system wrongly identified, doctor wrongly identified you are pregnant. So that's called as false positive. Positive in the sense pregnant. So false positive. Then fourth stage, the person was pregnant, but system wrongly identified you are not pregnant. So that's called as false negative. That's called as false negative. So there are four stages. Stage one, the person is pregnant, system correctly identified pregnant, that's called as true positive. Second stage, person is not pregnant, system can correctly identify not pregnant, that's called as true negative. Then fourth stage, a person having big belly, but system wrongly identified is pregnant, so that's called as false positive. So there, a person is pregnant, but system, that is machine or doctor, wrongly identified he is not pregnant. So you are not pregnant. That will be termed as false negative. So there are four stages. So what we desire from this true positive and true negative, but due to misclassification, we also end up with false positive and false negative. So anyway, we are getting true positive and true negative was correct, but sometimes the misclassification also happened. In that time, we are ended with false positive and false negative. So there is a confusion. So there is a confusion in classifying whether the person is pregnant or not. So this is because no machine learning algorithm is perfect. Soon we will describe a confusion in classifying data in a matrix called as confusion matrix. So for that purpose, we are describing the classification data in a matrix that's called as confusion matrix. Not all those machine learning algorithm works fine. So because of the confusion, which one works fine? For finding that, we build a matrix, okay? That's called as confusion matrix. Now we take a data set. Now we select 100 people data set. Which include a pregnant woman, not pregnant woman, a man with fat belly. So we take a sample data set which comprising of 100 people, which includes pregnant woman, not pregnant woman, as well as men with fat belly. So let us assume these 100 people, 40 are pregnant and 60 people are not pregnant woman as well as fat belly men. So 40 are pregnant, 60 are not pregnant. So now let us consider a confusion matrix. This is a confusion matrix. True, negative. So negative, negative, true, negative, positive, positive, true, positive, then false, negative, as well as false, positive. Now here, a person not pregnant, system identified not pregnant. So that's called as true negative. So person is pregnant, system identified pregnant, true positive. These two cases are success. But misclassification, a person having big belly, system identified pregnant. So that's called as false positive. But person pregnant, but system wrongly identified not pregnant, that's called as false negative. In these two cases, system works wrong. So this is what we construct a confusion matrix here. So based on this confusion matrix, I take example of 100 people graph, 40 people are pregnant and 60 people are not pregnant. So from that 40 pregnant women, my algorithm find 30 pregnant women are correctly identified, but 10 pregnant women are wrongly classified. So 40 pregnant women are 30 was correctly identified. So true positive was 30. 10 pregnant women was wrongly, sorry, pregnant woman, but system wrongly identified. So false negative was 10. False negative was 10. Similar way, 60 people are not pregnant. System identified 50 people correctly. So true negative was 55. False positive, 5 people, they are not pregnant, but system identified pregnant. So false positive as 5. So totally I take 100 people data set and 40 pregnant, 60 not pregnant. From that I am getting, this is what confusion matrix. So 55 for true negative, 30 for true positive, 10 for false negative, 5 for, okay. This is what confusion matrix was built. From that confusion matrix, I find the accuracy. From that confusion matrix, I find accuracy. What's the accuracy of machine learning model in this classification task? So I'm easily finding this true negative, false positive, true false negative, as well as true positive. So using that, so finding accuracy, this is the formula: true negative plus true positive divided by true negative plus false positive plus true positive plus false negative. So for adding this, 55 plus 30 divided by this, so 80% best one. 80% best one. Whether accuracy is a best matrix? Whether accuracy is a best matrix? Please see here. Is accuracy is the best matrix? So accuracy may not a good measure if the data set is not balanced. If the data set here 40 and 60, 40 people are pregnant, 60 people are not pregnant. So that's not a problem. But in that case, consider the following scenario. There are 90 people who are healthy. 90 people are healthy, that is negative stage. 10 people who have some disease, that is positive stage. 90 people are healthy, that is negative stage. So system identify only disease. So disease identification in the sense positive stage disease. So some disease. So here true negative equal to 90. System also correctly identified all those 90 people. But all the 10 diseased people, the person having tumor, so but system wrongly identified. Actually, I have developed a system, please listen carefully. I have developed a system for finding tumor, but my system wrongly identified 10 tumor people, wrongly identified, they are healthy. But 90 healthy people, system says healthy. So all the 100 data, my system says healthy. Then now this is for 90, this is for 10. So for finding accuracy, it's 90% best. Think about that. Actually, I build a model for finding disease, finding tumor. So totally only 10 people are having tumor, but 90 people are not having, they are healthy. So system healthy people healthy, tumor people also healthy. System says everyone is healthy, but the algorithm accuracy was 90%. So if the data was balanced, 50% healthy people and 50% disease people, then only the accuracy is a best matrix. If the data was not balanced, then accuracy is not a best measure. For that purpose, you can go for another matrix called as precision. Precision equal to, precision in the sense, now we will find precision for past predictive value. So positive predictive value, that's called as true positive divided by true positive plus false positive. So yes, this is for precision value. For recall is concerned, this is for true positive divided by true positive plus false negative. So here recall value is 0.75. Using this precision and recall, I find a F1 score, that is 2 multiplied with precision in the recall divided by precision plus recall. So my accuracy was only 79%. Actually 40-60 ratio. The pregnancy was, you will take 40% pregnant people and 60% not pregnant people. So 40-60 ratio, my accuracy score was, I think 85% around that. Accuracy percentage was 85%. But it's a not balanced one, not 50-50. So not balanced one. So for that, I will calculate the precision and recall score and find the final F1 score. The F1 score has only 79%. So 79%, 79.9% performance F1 score result. So this is what base. So starts from random forest regression. Next, I am entering into random forest classification. Then some of the performance metrics called as confusion matrix, precision, and recall score. Now I am entering into my IDE. So for random forest classification, then similar way I am importing packages. I will open a new command prompt. I will open a new command prompt e: cd sample, then Python, then I will paste that importing packages. So step number 1 was fine. So step number 2 for reading data from dataset. This dataset was classification dataset, bill authentication. So class 0. Then now I am entering into third stage for X and Y value. So first 3 columns taken as X, next column taken as Y. Then I will copy paste training and splitting test. So yes. So X train and X test was splitted. Now I will perform standard scalar of convert the values into 0 to 10. Then after performing the same, I will perform standard scalar, classification model creation. The model was fit. After converting the scheme, I can predict a confusion matrix. I can print the confusion matrix. So this is what confusion matrix 155 to 1117. 155 to 1117. So it will provide 98.90% accuracy. 98.90% accuracy. For plotting it in a graph, I will print the plotted value. So it's constructed for 5, 10, it's plot.show. It can plot. So like this. So 98.90, but in 500%, 98.55. So okay, this is not a accuracy, this is a mean absolute error. So value. So value was printed. So if needed, you can print F1 score too. This is what accuracy score. So here I am printing classification value. So accuracy score was 98.5. So this is what the algorithm was. So this is for algorithm as well as the performance metrics which helps you. So this is what today's plan. So I will summarize everything. So starts from base machine learning. Always machine can automatically learn based on our input data set. Not automatically learn based on previous history, which can learn something and predict the future. For that, initially we started with a linear regression algorithm. After that, we are entering into multiple regression. After that, we are entering into decision tree for regression as well as decision tree for classification. Then now we are entering into random forest for regression and random forest for classification. Now, at last, we will find the performance metrics. So confusion matrix, build a confusion matrix. Then based on that, you can find the accuracy score. So accuracy score is not a best matrix because the data set was not balanced. For that purpose, you will go for something called as precision, recall, and F1 score. This is a small overview for day 3.